Scott's Geography Notebook. Do you want to try saying it?
Da, da, da.
In the mid-latitudes where many of us live, most of our storm systems come from what's called a mid-latitude cyclonic storm. And so I want to talk a little bit about the progression of a mid-latitude cyclonic storm. Now, there's a few different steps that we're going to be outlining. We'll be illustrating each one of these, but we'll talk first about a stationary front. Then we'll start to move into the beginning, or Cyclo Genesis. We'll talk about an open stage for that storm system. We'll talk about an occluded stage for that storm system. And then we'll talk about the dissolving stage for that storm system. Now, all of this is taking place right here at this low pressure system. All right, so we're going to have our continental polar air and our maritime tropic air, and those guys will sometimes be pushing back and forth. In a previous discussion, we talked a little bit about a cold front or a warm front and the symbology that's used for each one of those. We're going to be using that same idea. So let's talk very first what is going to be happening. Well, we know that to the north, we're going to have our continental polar air, cold, dry, dense air, and we know that to the south, we're going to have our maritime tropic air. This will at least be in the northern hemisphere, mid-latitudes, where we start to see this. And what we will find is that there will be a line kind of dividing the two from each other. And along that line, symbolized on a map, we will have the cold air that's at the north. And we have the warm air that's in the south. And they're not getting too pushy back and forth. Okay? This is going to be referred to as a stationary front because it's not really moving. We're not seeing either one getting too pushy. A stationary front. Now, what can happen with this guy is we're going to have all of our warm, moist air here, our cold, dry air here. If we get a wee bit of a low pressure system, then wild and crazy things are going to be happening. The very first thing that we start to see is what we refer to as Cyclo Genesis. Okay. So we get a little bit of a low pressure system happening along this line. And with a little bit of a low pressure system, we remember that that low pressure system, that's the air rising up off the surface. Because it rises, it starts to rotate ever so slightly. And because of Coriolis, we start to see that rotation. And as a result, we have our continental polar air to the north. We start to see along this side a cold front. And we have our maritime tropic air to the south. And because of that, we start to see along this edge a warm front. This is the beginning of the cyclonic system. Cyclone meaning that rotation. And so we refer to this as the beginning, or Cyclo Genesis. And it's all one word, but I'm going to put a little hyphen there so we can think about it as being a rotation. Cyclo Genesis, the beginning or the creation of a mid-latitude cyclonic storm. All right. Well, what continues to happen? This cold air continues to creep its way down. This warm air continues to go up. However, a cold front moves faster than a warm front does. So in general, what we're going to start to see is this low pressure system is being blown along. It's going to be usually moving from the west to the east. And we start to see both of those fronts. So we have this low pressure system. That air is spinning and rising and lifting. The cold front is moving a little bit quicker. Okay? And so when we draw that guy in, it's going to have its jagged teeth. Along that side, again, rotating around, we're going to have a warm front over on that side, and it's open. And what it's open to is this maritime tropic air. Okay? We know that cold, dry, dense air, continental polar air, this guy is kind of heavy. It's not necessarily heavy, but it's going to be more dense. And so it's typically going to be sinking, or it's going to be causing a higher pressure. It's this moisture that's in here that's causing that lift. And so what we see is we still have an openness. This low pressure system still is able to get the warmer air and the humidity. And the humidity is going to be a big deal because as it rises, we get a phase change of water that releases latent heat energy, and so we get more lift there. And so what we have here is it's open, and so we call this our open stage of the storm. Okay? But the problem is that this cold front moves more quickly than the warm front does. And so what we're going to move into next is where we have our low pressure system. And that cold front has been a lot faster. So maybe at one point we had our warm front and our cold front. But now what has happened is that cold front has come in and kind of taken over. And so we have a bit of a cold front right here. We have a little bit of a warm front going on right here. But in this region right in here, that's referred to as an occluded front. The way we symbolize that is with a little jagged and then a little curve and then a jagged. And if we had room, we'd put another little curve right there. Now they're both going the same direction, but here's what we've got going on. We have occluded that low pressure system. So our maritime tropic air, the fuel basically for the storm, if you will, it's completely been cut off. And so what we see is continental polar air here, cold, dry, dense air, and that is what is being pulled into this low pressure system now. Remember that low pressure system continues to have that spin on it, but now it's just pulling in cold, dry, dense air. Continental polar air is not going to be encouraging that. So we've started to kind of pinch off or occlude that low pressure system from that warmer air. We refer to this as the occluded stage. Okay. Well, that tends to be a problem for our low pressure system, because then what starts to happen is we get this poor little low pressure system off on its own. It's completely surrounded by cold and dense air, or our continental polar air. And so it's just going to be pulling in this, and it's starting to get weaker and weaker and weaker. The low pressure system gets weaker because it's pulling in the cold air. Well, what happened in the maritime tropic air? It is still going to be there. There will be another line because that low pressure system has kind of pinched itself off. This will have my continental polar air on one side. It will have my maritime tropic air on the other side. Oh, strike that, reverse it. These should be curved. These should be jaggedy little teeth. Good. And we refer to this because this guy is sort of dissolving. We call this our dissolving stage. However, if you've been taking notes, then you should recognize this little line. That little line is what we saw way back here when we were looking at our stationary front. So we get our stationary front and we get a little bit of a low pressure system developing, that little low that we have right in there. Then we're going to start to see some more rotation. We're going to see some Cyclo Genesis. And then the cold front and the warm front is going to be developing. And then eventually the cold front is going to be overtaking that warm front. We get to the occluded stage, and then that poor low pressure system's out there all on its own. they're all getting out of order. And it's all on its own, so it's dissolving. But then the next thing that we're going to be seeing is that stationary front there. And as a result of that stationary front, then maybe we get a little bit of a low pressure system and we get Cyclo Genesis happening. And then we start to see that open stage, and then it develops into an occluded front, and it gets all lonely over there. So it becomes a dissolving stage, but then we have our stationary. It just keeps going and going and going. We can flip through this. This is going to be that storm system. Now, sometimes those storms are going to be a little bit further north during our northern hemisphere summer. That's when we're going to mainly have this high pressure system, remembering that these guys are all going to be shifting back and forth. So in the summer, it's high pressure system, and these storms are still there. They're just further north. But in the winter, that's when we start to see them dip down a little bit.